When reactions involve gases, measuring concentration isn't always practical. So, how do chemists keep track of equilibrium when everything is floating around? In gas reactions, particles spread out to fill the container. That makes the concentration hard to pin down, but the pressure they exert is easy to measure. In this video, you'll learn how equilibrium expressions change for gases, how to write K sub P, and how it connects back to K sub C. So far, equilibrium expressions based on concentration, also called K sub C, work well for solutions, but gases behave a little differently. For gases, we rely on partial pressure instead of concentration. In a fixed container, gas particles push on the walls, and that pressure is easy to measure. Thanks to gas laws, pressure becomes the most convenient way to describe how much gas is present at equilibrium. So instead of concentration brackets, we use partial pressures. The equilibrium constant becomes K sub P instead of K sub C. Let's walk through an example. This reaction forms nitrosyl chloride gas from nitrogen monoxide and chlorine. Writing K sub P follows the same rules as K sub C. Products go on top, reactants go on the bottom, and exponents come from the coefficients. For this reaction, K sub P equals the pressure of nitrosyl chloride squared over the product of pressure of nitrogen monoxide squared and the pressure of chlorine. Once the expression is set, you substitute the equilibrium partial pressures and calculate the value of K sub P. With nitrosyl chloride at a pressure of 1 atmosphere, nitrogen monoxide at a pressure of 2 atmospheres, and chlorine at a pressure of 1 atmosphere, the obtained result of K sub P is 0.25 inverse atmospheres. So far, we've seen how gaseous equilibria use partial pressures and how K sub P is written from the balanced equation. Want to check your progress? Tap the link for a quick practice test and a concise study guide tailored to this lesson. Quiz yourself, skim the highlights, and jump back in. Now, let's connect everything we've learned. K sub P and K sub C are related, but they're not always equal. They're linked by this equation, where delta N is the sum of the stoichiometric coefficients of the reactants subtracted from the sum of the stoichiometric coefficients of the products. If the number of gas moles changes during the reaction, K sub P and K sub C will be different. But if the number of gas moles stays the same, delta N is 0. So K sub P equals K sub C. This detail often causes mistakes, but spotting delta N makes it much easier to know what's happening. To recap, gaseous equilibria use partial pressures. K sub P is written just like K sub C, and the two constants are connected through delta N. Ready to quiz yourself with the content covered in this video? Check out the link in the description where you'll find Quizlet content made just for you.